everybody, it's Mrs. C, and I am coming to you with a video today from our workbook. Pretty much I'm using the lessons that are 4.2 and 4.3, I'm hoping, to go over some of the details, I guess, or the things that you need to know about how you graph a function, and also how you identify if ordered pairs are solutions to the function. So if you take a look right now at your workbook page, it's, oh gosh, what page is this? It's 49 in your workbook. It's lesson 4.2. This is just a quick screenshot for you of the work that I'm doing. I'm going to move on over to the next page for now because it's a little blurry and dark, and I don't like blurry and dark. So I'm moving over. You know what you're looking at. I'm going to take a look at problem number 1 here, though. So I guess before I move, I should just address that problem. The directions decide which of the 2 points lies on the graph of the line, and the line is 2x plus y equals 10. So I guess what you find in the future, it's not right now, but you find that if you're given a equation in 2 variables, in this case the x and the y, you can graph that on a coordinate plane. And so we're going to be putting all of that together. But right now they're just asking us, given 2 different coordinates, which one actually satisfies the equation. So we really don't have to graph it. We could, but we could just use some old school techniques. So what I mean is we could start with the 2x plus y equals 10. That's the function that they gave us. And then they gave us 2 ordered pairs and said which one of these ordered pairs is a solution to it. Or their words were decide which of the 2 points lies on the graph of the line. So you might be thinking, how am I supposed to know that if I can't see the graph of the line? Well, I'm going to tell you. Here they are. It was 4, 3. That was the first one. And negative 4, 18. Now, if I have a choice, would use a graphing calculator for this, but I don't know if I can use a graphing calculator on the assessment, say, and I need to know how to do this old school. So, plug and chug is what we call it in the algebra world. We're going to take the x value, you know an ordered pair. The first one is x, the second one is y. So we're going to take those values and plug them in to the expression or the equation that we're given, and then chug out the solution. Now, if x, in this case, is 4, then that would be a 4 there. And in this case, if y is a 3, this would be a 3. Now, what we have to do is evaluate this equation and see if the sides are equal. That would mean that this is a point that lies on this line. If it is not equal, then we will know it is not. So, let's figure out if it is or if it isn't. 2 times 4 is 8. Plus 3, oh, that's not looking good. 8 plus 3 is 11, and 11 is not equal to 10. So what that means is this ordered pair does not fall on the line of 2x plus y equals 10. Now you might think then obviously negative 4 must work. I don't know if there's any obvious, so I am going to just try it out. So I'm going to erase it. And I'm going to rewrite my equation. That's an eraser. I'm going to rewrite my equation, 2x plus y equals 10. And now I'm going to plug and chug with the negative 4, 18. All right, so substituting the x value, I'll change my colors when I do that little substitution. This is the x, this is the y. So I'm going to plug in a negative 4 here, right? And I'm going to plug in an 18 there and see if I get a true statement this time. Well, 2 times negative 4 is a negative 8, and 18, so plus 18 equals 10. Oh, yeah, negative 8 plus 18, different signs, find the difference, sign of the higher number. 10 is equal to 10, check, check, yay! So negative 4, 18 is a solution to the equation, and it is also, when you graph it, a point that falls along the line, within the line of the graph. Now, for those of you using your graphing calculator, we have a whole different lesson on how to go about that, so for now, we're just going to be happy that we got that right. Go back to this page, even though it's a little bit, blurry. That would have been the correct answer. All right, now we take a look at the next, though. That's how you would do 2, and that's how you would do 3. But let's take a look at the next one. It says solve the equation for y. Solve the equation for y. What does that mean? It means, like in a literal equation, when they give you negative 6x plus y equals 11, solve for y. They want you to get y by itself and move everybody else over to the other side. That's why I taught you literal equations, my dear children, so that you could apply it when we got to our Unit 3, which is where we're at right now. So let me erase this, and let's write the new problem. I kind of like the yellow. What do you think? I find it nice. Let's do. It was a negative 6x plus y equals 11. That's number 4 in your workbook. Directions, solve for y. That's not a J. That's supposed to be a semicolon. So solve for y. That means I want to get y by itself, move everybody else over. Now, I know you guys had a problem with literal equations. Some of them can be super saucy, but normally in this unit, the literals that we do, we're almost always solving for y, and they're almost always pretty straightforward to get y by itself. As you can probably see here, what do we have to do to get y by itself? Pausing. Yes! I'm so proud of you. You got that so quickly. You're going to add 6x to both sides. And guess what? Y is by itself. And I like to put the x term in the front. You'll probably realize that a little bit later. I'll explain why, but I like to put the x term in the front. Do you have to put the x term in the front? No. You could have said y is equal to 11 plus 6x. That would have been fine. Box your answer. That's it. I solved for x. Now I'm going to go back to the workbook. You can go back to the page if you want. Oh, what the heck, I'll do it for you. Go back here. So this answer was y is equal to 6x plus 11. I want to do another one. I want to do number 8. All right, so you see number 8. Why don't you copy that? And I'm going to go ahead and do number 8. So number 8, 10x minus 5. Y equals 25. Again, we're solving for y. The directions were the same for these 4 through 9. And to solve for y, I want to get y by itself, this little guy. But there's a little bit more I have to do. So the first thing, in order to get y by itself, I want to move everybody on the outside. That would be the x. So I'm going to minus my 10x, minus my 10x. Nothing new here, guys. We did this in the beginning of Unit 1, in the middle of Unit 1. So I have a negative 5y equal to a negative 10x. Remember, I put the x term in the front because that's the way I like to do things. And then I plus the 25. And so right now I have a negative 5y is equal to a negative 10x plus 25. And you might be saying, aha, I'm done. I got the y by itself. No, you didn't. No, you didn't. Yes, I did. No, I didn't. Yes, you did. No, you didn't. Yes, I did. No, you didn't. The y is not by itself. There's a negative 5 on it. Got to get rid of that. So in order to get rid of the negative 5, I divide by a negative 5, but be careful. Divide everybody by negative 5. So important. Everybody. What you do to one side, you do equally to all terms on the other side. So that cancels out, leaves me my y. But I got to do a little quick mathy math. Negative 10 divided by a negative 5 is a positive 2. And don't forget the x. 25 divided by a negative 5 is a negative 5. 25 divided by 5 is 5, and a positive divided by a negative is negative. So that would be the final answer. Y is equal to 2x minus 5. That's solving for y. You repeat that process for 4 through 9, as those were the directions. Okay, now I want you to take a look at oh, you can't see it, so I have to fix it. Let's see. Can I move it a little bit? I can move it a little bit so that you can see numbers 10 through 12. There's actually 10 through 15 here. So let me read the directions for those. Graph the equation. Now they give us graphs. I didn't teach you how to graph an equation yet. And I don't plan on teaching you how to graph an equation yet. So how the heck are you supposed to graph an equation if I'm not going to teach you how to do it? Ooh, isn't that questionable? Yes, it is, and I've got a solution for you. Let's take a look at this equation. Now I'm just going to copy number 10. It read y plus x equals 14. Now, if I'm not going to teach you how to graph this in this form, I'm not going to give you any information about how to graph. I want you to think what we did in problems 1 through 3. Now, in problems 1 through 3, if you rewind or if you just use your memory, we were given an ordered pair and we plugged and chugged. We plugged in the values and we decided whether it was equal. And if they were equal, then we wound up knowing that those were solutions. So we're going to use a similar process right now. We're going to set up a table of values. Now, you've done tables of values before, but what's new here is I don't think you've ever created your own, because I'm not telling you what x or y are equal to. Y and x could be equal to pretty much any number. But the problem is y and x can't just be random numbers, and I'll explain, or I'll kind of show you why. If I pick a value of y, say it's 2, and then I pick another random value of x and I say it's 5. Is 2 plus 5 14? No. See, I've got to pick an x and y value that actually add together to give me 14, because that's what this equation says. So when I pick a value, when I set, say, for example, x to be equal to 2, I like a 2. If I set x as 2, that is going to force y to be one value and one value only. Do you know what that value would be? If x was 2 in my table of value, what would y have to be in order for the left side to equal 14? You're so smart. Yeah, it would be 12. So where I can make up the value of either the x or the y, that I can't make up the value of the other one. It is going to force the other variable to be equal to something. So let me give you an example up here again. Say I pick a number, any number. I'm going to pick the number 6 for y. I'll put it down here in my little table. I pick a value of 6 for y. That forces x to be equal to something. It has no choice. What would x then have to be if y plus x had to be equal to 14? Yes, my gosh, you said it before I even finished my question. It would have to be 8. So once you pick one, it forces your hand on the other one. Let's pick a little number. I like picking my x's personally. I like to do my x values. I'm going to pick a 1. If x is equal to 1, then y would have to be equal to what? It would have to be equal to 13. Do you see how easy this is? I find it like super easy. Now, that's how you would do numbers 10 through, how you would graph numbers 10 through 15 is by setting up a table of value. But you might be saying to yourself, okay, I get how to make a table, but how's that helping me graph it? Well, I'll explain how it's going to help you graph it. We now have 3 ordered pairs. I have a 2, 12, an 8, 6, and a 1, 13. So I want you to go to your graph paper for number, I'm going to write these down so I'm going to lose my page. So write your ordered pairs down, or pause whatever you need to do the screen. I'm writing, I have a 0.212, an 8, 6, and a 1, 13. I know you're saying, I don't see you writing that. That's because I'm writing it on a real piece of paper. I have ordered pairs 2, 12, I have 8, 6, and I have 1, 13. And I'm going to plot those points. I'm going to go back to actual graph paper. Now, this graph paper is a bit on the tricky side. I can't move it up, so I need to be able to do a little bit better, a little bit more proper of a graph. So let me go to some nice graph paper here. I'm going to the graph paper. It's not giving me graph paper. Give me graph paper. What's your problem? Don't like that? Okay, it doesn't want to do that. That's okay. Oh, okay. I see how it's going to be. All right, there it is. Now, I'm going to try to mimic or replicate, maybe is a better word, the graph that they gave me. So, let's see. We have an ordered pair. We have a coordinate plane such as about like that. And then they specifically set my intervals. So you're looking at number 10 in your workbook. If you're not, that's okay. But I want to just explain that they give me the first line is a 4. Now that means that this paper is not very good, so I'm going to change to, yeah, bigger paper. Okay. Hold with me for 1 second. Okay. Doing this really on purpose because I think it's important for you to see. You're stuck using their little coordinate plane that they set up. And so what we have is we have this interval is a 4, then it skips, and then it goes, this interval is a 12, and it goes a little bit higher. I am out of space, so I can't. Then it says that this is 4. Then obviously, maybe not so obvious, that would be -4. This would be also -4 here. This would be -12. Okay, so that's what we're dealing with. And I know it's a little bit confusing to look at it that way. I apologize. So when we're graphing their ordered pairs that we got, I am going to just erase these numbers because I know I'm intervals of 4, and I feel like those numbers are going to really confuse me. I'm probably going to confuse you too. So my first ordered pair that I was asked to graph was 2, 12. And so where is the 2 on the x? It would be halfway between the 0 and the 4, right? And then where is the 12? The 12 was up here. And so remember, when you graph ordered pairs, it's where the 2 intersect. So my point would be up here. That is my ordered pair. And we could call it A. We could call that point A, 2, 12. Now if I do 8, 6. 8, 6, if this interval is 4, then this interval is 8. And so my x value of an 8 would be right there. And then I would need to go up 6. And if I'm going in intervals of 4, it would be this first one is 4. Then it would be, another 4 would be 8. And then another 4 would be 12. Well, I don't have a 6, do I? 6 lies somewhere between 4 and 8. So I've got to be between those two. And so I'm going to do a quick little point there and say that that would be B. Now, last one, 1, 13. So 1, my gosh, 1 on this scale is really like way right there, really close to the origin. And then I've got to go up almost off my page. I hope I can even get there. I don't even think, unfortunately. Can I move this down a little bit? Oh, thankfully I can. I was going to say I don't even have room. I'm going to extend that a little bit. There we go. So 113 would be about like there. So if I connect those points with a line, and let me connect them with a green line. Oh gosh, all right, not very good. That's better. Okay. If I connect them with a line, there is how I graph using a table of values. Now, there's a much easier way, or I don't want to say easier, much faster way to graph without having to set up a table of values every time. But right now, because this is 4.2 and they haven't given us any more information, we're going to use this method, creating a table, and then going from there in order to graph it. When you have a graph that is already set up for you, like this, within these intervals of 4, you're stuck graphing on that graph. You can't set up your own intervals the way you want. You have to deal with what you're given. You have to play the hand you are dealt. So that is how we are going to work in Unit 4.2. I'm only doing 4.2 today. If you want to practice these skills, I would say try a couple of the problems on page 48. It's page 48. It's 1 through 13, 14, 15. And when you come back in class, we are going to go over these skills. So when you come back in class tomorrow, be ready with your questions. I only did one example of these graphs because I don't want this video to go much past 20 minutes because I want it to be enough information for you to digest. And there was a lot going on in this 20 minutes. So I hope you're paying attention. I hope you come to class with questions so that I can answer the specific questions you had that I did not address today. And you can tell I'm talking really fast because I have a class coming in real soon. So I'm going to have to say for now, peace, see you on the flip side. Later.